Programming FPGA boards with TINACloud using Schematic Design Entry. In this tutorial video, we'll show you how to create a digital circuit and download it to a Digilant Basis 3 FPGA board by using TINACloud's schematic editor. In a similar way, it's also possible to download digital circuits to the FPGA of DesignSoft's Lab Explorer. The schematic design may contain gates or other built-in digital components in TINACloud, or macros defining digital components with hardware description languages such as VHDL or Verilog. In this video, we'll use a free Xilinx tool, vivato, which is required for the FPGA in Digilant Basis 3. For other FPGAs, e.g. Xilinx's 7 series, except Spartan 7, you can use Xilinx's ISE Webpack. These tools will be responsible for creating configuration files for the FPGA programmable logic. Now, let's see an example. Start TINACloud, then open the half-addergates.tsc file from the examples folder of TINACloud. The half-adder is a simple combinational circuit to add two single binary digits and provide the output plus a carry value. It has two inputs called A and B, and two outputs called sum and carry. This schematic diagram contains basic OR and inverter gates, high-low switches, and logic indicators. Note, you can find more information about the half-adder circuit in our previous video, Simulation of Half-Adder with 4 gates using TINACloud. To test the circuit, press the Dig Interactive button. Play with the switches by toggling between low and high levels to produce all the input combinations. If both inputs are low, then sum and carry are also low. If just one input is high, then sum is high and carry is low. If both inputs are high, then sum is low and carry is high. Now, before testing our circuit in a real FPGA development board environment, we need to extend our schematic with FPGA pin connectors from the special toolbar of TINACloud. Pin connectors as certain elements such as clocks, push buttons, and LEDs are pre-connected to the FPGA chip's pins on the development board. The FPGA development tools call them constraints. Now modify the schematic by adding the FPGA pin connectors. Select FPGA pin from the special toolbar and add 4 FPGA pins to the circuit's inputs and outputs, as shown next. Connect the first FPGA pin to input A. Double-click pin 1, and in the Properties window, click the 3 dots at the end of the pin settings field. The FPGA pin settings window appears. The device section of the window contains the list of supported boards in the TINACloud system. In the Group section, the types of input-output parts, e.g. switches of the selected board, e.g. Digilant Basis, are listed. Once you select a type in the Group section, e.g. switches, in the Pin section the connection pins of the selected type of parts appear, e.g. SW0. These connection pins should be associated with the corresponding nodes in the TINACloud schematic. We'll rename the FPGA input and output pins, including their labels, accordingly, as those on the FPGA boards, to which they will be connected. For the inputs, we will use SW0 and SW1, and for the outputs, LED0 and LED1. From the device list, select the Digilant Basis 3 Artix 7 FPGA trainer board. Next, click Switches under the Group section, then select SW0 from the pin list on the right side. Then click OK. In the Properties window, rename label pin 1 as SW0 as well. Then click OK. Select the next FPGA pin and connect it to input B. Then rename it as shown next. rename its label as well. Now connect the half-adder circuit outputs to the LEDs. Place the FPGA pins and select the proper entries. For some, use the LED 0 as output. Repeat this procedure for carry. Rename carry as LED 1. Okay, now let's see how to generate the source file for Xilinx Vivato. Click the TNM menu and select Export to Xilinx tool. Then click Xilinx Vivato. Next, open and extract the half-addergates Xilinx export.zip file. Create a folder, and we'll name our folder Designs. Then copy the two files, VHDL and XDC, into this newly created folder. Note that TINACloud always creates a VHD file from any type of representation of the digital circuit. That is, schematic diagrams, VHDL, Verilog codes, or their mix are always translated into a VHD file for Vivato. The XDC, Xilinx Design Constraints, guides the Xilinx software on which physical pins on the FPGA will be the inputs and outputs. The XDC is made from the FPGA pin settings we made previously. To produce downloadable content, first we create the Vivato project. Start Vivato, click Create Project, enter the project name, in our case half-addergates, then click Next. Click Next again, then click Add Files. And from the Designs folder, select the half-addergates.vhd file as a source file, then click OK. Next, select VHDL as target language. Click Next again. Click the plus sign to add the half-addergates.xdc file as well. Then select the Add Files option. Click the half-addergates.xdc file and click OK. Click Next. To finish project configuration, select Boards in the Default Part dialog. You can now select the appropriate board. Select Basis 3. Note, if you cannot see Basis 3 board in the list, you can choose it manually under Parts. There, you should select part the number, click Next. Click Finish. Now Vivato is initializing our project. We can check the half-addergates.vhd file, and the half-addergates.xdc file. Click Generate Bitstream to produce configuration data for the FPGA. Then click OK in the Launch Runs dialog. Now connect Basis 3 via USB with the Vivato machine and turn the board on. As soon as the Bitstream Generation Successfully Completed message appears, select Open Hardware Manager, then click OK. Next, click Open Target. Let's finish programming the hardware. Click the FPGA part name, then select Program Device. In the Program Device window, click the Program button. You'll see the message FPGA is programmed, and the Done LED will light up on the board. Now let's see how our simulated half-adder circuit works along with the programmed Basis 3 hardware. To have a closer look at Basis 3 hardware, we'll now zoom into the area of the two switches, SW0 and SW1, and the corresponding LEDs, LED 0 and LED 1. Start the simulation by pressing the interactive dig button in TINACloud. We'll change the virtual switches in TINACloud by clicking them on the screen, and at the same time we'll also change the real switches on the Basis 3 board. If both inputs are low, then sum and carry are also low. If just one input is high, then sum is high and carry is low. If both inputs are high, then sum is low and carry is high. As you can see, in all cases the results are exactly the same. This is a great example of demonstrating the power of simulation, since you can test and debug circuits even before realizing them. And in our case, before downloading to FPGA, where if there were any issues, it would be extremely hard to find the problem. This concludes our video tutorial of programming an FPGA development board using schematic diagrams with TINACloud's built-in digital components. Check out our video, Programming FPGA Boards in HDL using TINACloud, where we use VHDL and Verilog components in FPGA design. For more information, visit our website, www.tinacloud.com. Visit our YouTube channel, www.youtube.com/user/Tina Design Suite.